The 21st century workplace requires a technologically proficient workforce for the changing marketplace. The Business and Higher Education Forum highlighted the needs for such skills in 2005, stating that workers of the 21st century must have science and mathematics skills, creativity, information, and communication technology skills, and the ability to solve complex problems. The National Science Education Standards definition of science literacy states that students can determine answers to questions derived from curiosity about everyday experiences. The science classroom provides an excellent opportunity to engage students in interdisciplinary inquiry while integrating technology to prepare students for the careers of today and those of the future. Visual literacy is an integral part of our changing society, and it is vital that we place the same educational value upon it that we currently do with traditional textual literacy, as it has been identified as the essential literacy by the Partnership for 21st Century Skills. It will be essential for the educators of today to understand what visual literacy is and to instill it in the students who will shape our future society. Technology provides an excellent instrument to improve visual literacy instruction by providing realistic and practical visual literacy training in the classroom that cannot be achieved with traditional methods. Visual images in the science classroom. The science classroom of today makes heavy use of visual images and incorporates many aspects of visual literacy. Science teachers, often without realizing, are teaching students vital visual literacy skills in a variety of ways. The National Education Technology Standards for Students calls the use of technology to support student learning of core area concepts and processes and tools for the 21st century collaboration and communication. Graphing is an important way to display data in a way that can be interpreted much more quickly than can be done by reviewing the data in a table format. The Earth Science Reference Tables uses a graph to display the velocity of earthquake waves. This graph is an excellent example of visual thinking where students transform information into a graph that improves communication by providing a visualization of the data. Students can use this graph to construct meaning and determine the distance between seismometer recordings and the epicenter of an earthquake. A competent teacher could ask students to construct their own version of this graph and to reconstruct meaning for students by extrapolating information that is not on the graph and ask them to infer beyond the data line that they have constructed. In meteorology, synoptic weather maps are used to visually display data that would otherwise make a map unreadable with a vast amount of weather data collected at a given time. By learning how to create the symbols in these field maps, students become fluent in their interpretation. Students are able to interpret the man-made symbols they encounter on this map, intentionally communicate the information to others, and reconstruct meaning by predicting future weather conditions based on current observations and thinking visually. Another use of visuals in the science classroom is to create a model of science experiments so that students can recreate an experiment. When accompanied by a list of materials and a set of procedures for assembling laboratory equipment, students can reliably set up experiments with little to no teacher support. The image and text provide a multimodal explanation of the experiment that students interpret and use to create their laboratory setup. All of these examples are excellent means to improve the visual literacy of students in the science classroom. However, the question that begs to be asked when developing science curriculum is, can we do better? The answer is an unequivocal yes. By incorporating technology into these activities, we can involve additional modalities to enhance visual literacy and better prepare students for society rooted in visual imagery. The next step, integration of technology. While there is nothing wrong in using static images to teach visual literacy, technology can improve upon them and their effectiveness in the classroom by enhancing student motivation. Several aspects of technology, including video, interactive models, and 3D software, can improve visual literacy instruction in the science classroom. While teaching students to interpret visual data, video can support instruction. In the example of the Earth Science Reference Tables, the information, when supplemented with auditory instruction and colored graphics, can be brought to life. The Homix Middle School Science Department has created a series of YouTube videos that support learners as they interpret New York State's earth science reference tables. Another example of an improvement upon existing teaching methods is in the area of field maps, like the synoptic weather map discussed earlier. These GIS maps are a new tool that teachers can utilize to promote spatial thinking skills in the development of models. New software, including ArcGIS, has enabled these static maps to become fully functional, three-dimensional models that not only display data, but can allow for users to choose layers of field data to overlay upon an existing map. The best function of these GIS programs is they allow students to input field data that they have collected and see their work presented in a three-dimensional field model. The current generation of GIS modeling software, including ArcGIS, have allowed students to create not just models but fully formed stories that demonstrate student comprehension through multimodal presentations. Finally, technology allows teachers to switch from using images of models to interactive models. Rather than using an image that corresponds to a laboratory setup, teachers can provide a step-by-step interactive model that gradually builds in front of the student so they can visualize what the laboratory setup will look like after each step of the procedure, rather than having to work backwards from a finished model. This idea can be taken one step further to create an interactive simulation that students can construct and interact with. Some models cannot be reproduced in the science laboratory. The Regents of the University of California created such a model in 2006 that allows students to manipulate the variables that control Earth's seasons. These digital models improve students' mental models of the physical world. It is important that educators utilize the affordances of technology when countering the constraints of traditional instruction in the classroom. Technology isn't merely something that interests students, it is an educational enhancement that provides students the opportunity to learn important technological skills in the process. As such, teachers should look to implement technology when they encounter traditional constraints. Getting teachers to adopt technology can be difficult, as they are likely to see technology use as an imposition from outside their typical work. Also, teachers are not always aware of new technologies, and teacher preparation programs can demonstrate to teachers that technology can enhance their ability to teach concepts, making them more likely to incorporate it into their classroom instruction.